Hello and welcome to day 9. Day 9 for me, not for you, because it is the 16th as I record this, and we're going to dive in. Okay, so day 9, encoding error. We're on ease at this point in the alliteration. With your neighbor happily enjoying their video game, yada yada yada, puzzle input, there's the puzzle input. We get an exchange masking addition system. Encrypted with an Xmas, Christmas. So it starts by transmitting a preamble of 25 numbers, and then after that, each number you receive should be the sum of any two of the 25 immediately previous numbers. The two numbers will have different values, and there might be more than one such pair. Okay, so basically we need to find two numbers in the previous 25 that will match the 20 that will sum to a current value. So the 26th value should match should be the sum of two previous numbers. 26 would be a valid next number. Okay, hang on. So if we have numbers 1 through 25, 26 would be a valid number, or many other pairs like 2 and 24 would be 49 would be a valid next number, as it is the sum of 24 and 25. Anything higher than 49, though, would not be a valid number because no two of the previous 25 numbers sum to 100. 50 would also not be valid, although 25 appears in the previous 25 numbers. The two numbers in the pair must be different. So we are, in fact, looking for two different numbers. So all of our numbers should be unique. Okay, so we'll do this. We'll build this. Apparently, we're doing a 5 for the preamble, so we'll build in some kind of preamble length to our function for part 1, or maybe we'll just have like a global that we'll call preamble size is going to be 5, and let's input this data. Okay. Okay, so for part 1, we're going to go through, and we know that we've just got integers here, right? This is what our input is going to look like. So let's take this and let's do data equals list map int data. And let's just make sure. Okay, so yeah, so now we get a list of all of those different integers. Perfect. Okay. So our preamble size is 5, so we will just use that as a reference point so that we can change it to 25 later when we switch to the full data input. But for right now, for testing purposes, we'll stick with 5. Okay, so let's go back to the stated problem. Okay. Here's a larger example that only considers the previous 5 numbers and has a preamble length of 5. Okay, so we're going to start with 2, 3, 4, 5. We're going to start with this number, and then we're going to continue and look at, okay, is 40 the sum of any two numbers behind? But in front of it, it's the sum of 25 and 15, etc. And we're going to go down the line, and we're only going to consider the 5 previous. Okay, so we're going to say for x in range length data, but we are going to start with current is going to be data here, and we're going to say preamble size, right? So this is our current x in range length data, and we're going to start with the preamble size, and we're going to go all the way out to the length of the data. Okay, and we're going to see if we're going to say for x in range preamble size, let's actually create a function here that we're just going to call is sum of two vals, right? And we can just check and see whether or not this is actually the sum of two different values. We're going to put in the number, and we're going to put in the preamble. We'll just call it preamble here, which is going to be our list of integers, right? This is going to be a list, and this is going to be an integer right there. And we'll test that, and then we'll, so if data x if is sum of two vals, x, data x, right, and current, right? So that's what it's looking for. So if it's the sum of two values, then we can continue. Otherwise, we would return the data x value. So what we're going to do instead is we're going to say if not that, then we return this, and we don't have to worry about all these extra lines right there. Okay, so relatively simple. Now we need to increase the size. We need to essentially change our current. So current is going to be current 1 through the end plus our data x. So there we go. I think that will work. Hopefully that will work. Okay. And theoretically, this will return up here, and we don't actually have to return anything down here. Okay, so now let's build out this part. We're going to iterate through our preambles, and we're going to say for x in preamble, then we're going to say if num minus x in preamble in there, then we're going to return true. Else, actually we don't need the else, we can just say return false. Okay. Now there's one tricky thing here is that if x is exactly half the size of num, then we don't want to count itself, right? So if num is 2 times x, we don't want to consider that. So we say and num minus x does not equal x. Okay, so basically num minus x does not equal x, or x plus x does not equal num. That would also work. Or x times 2 does not equal num. Okay, so let's try this and see what it gives us. 127 is the answer that we're getting right now, and that is in fact the correct answer for the sample. So let's get the puzzle input, very bright as usual, and we'll put this into our input right. Wow, those are big numbers. Okay, this is exciting. Big numbers. Okay, and we need to change this to be 25. So we're finding the first value that is not the sum of the previous 25 values. 36,845,998. Okay, let's put that in and let's see if we got that right. Hopefully we did. Yes, we did. Okay, that is the correct answer. So that's good. So we'll continue to part 2. Okay, so the final step in breaking the Christmas encryption relies on the invalid number you just found. You must find a contiguous set of at least 2 numbers in your list which sum to the invalid number from step 1. Contiguous, of at least 2 contiguous numbers. Oh, so it might actually be more than 2 contiguous numbers. Okay. Okay, yep. So let's use this input again. Okay, so adding up all of the numbers from 15 through 40 produces the invalid number from step 1, which is 127. Of course, the contiguous set of numbers in your actual list might be longer. To find the encryption weakness, add together the smallest and largest number in this contiguous range. In this example, these are 15 and 47, producing 62. So we add together the smallest and the largest values in a contiguous set. Now, it's going to be contiguous of at least 2 numbers, but we know that it's not going to be 2 numbers, right? We know that it's actually going to be at least 3 numbers because we already tested it, and that number does not sum to, there are no 2 values that sum to that particular number, but there are going to be 3 or more that are going to be contiguous, which means that they're all in a row in our input data. Okay, so we're not going to start with 2, we're actually going to start with 3 because we already, basically the first step guaranteed that there isn't 2. There's going to be more than that. Okay, so let's dive in. Okay, so I'm going to say that our end is going to be 3. We're going to say while true, for start in range length of data, right? Actually, let's do something slightly different. So we're going to say that one answer is going to be okay. So we're going to have that, and we're going to pass in P1 answer and our data. Okay. What did I do? Oh. Okay. Okay, so we've got our data, and we have our end values. Okay, perfect. So we don't actually care about the preamble size at all anymore, do we? No, we don't. So for start in range length data, we're going to have if sum of our data for start all the way to start plus end, not eden, if that sum equals, I'm going to call this my number equals my num, then we're going to return the minimum of this plus the maximum of that, and we're going to say as we go through and plus equals 1. Okay, so basically as we iterate through, we're going to get larger and larger end and potential. This is start plus end. This will never be greater than length data and minus end, right? We actually need to, otherwise we could end up with like an index error, I think. Okay. Okay, let's test this out. None. Oh dear. Do we have some kind of infinite loop? Okay. What do you want to bet that it was? Again, consider the example above. Adding up all the produces the invalid number from step 1, 127. The set of numbers in your actual list might be longer. 15, 25, 47, and 40 equals 127. Oh, our... So the first value came back as none, so of course none of them are going to sum to none. Duh. Okay, so our P1 answer is actually going to be 127 is what our goal is here. So let's test this. 127, and that is going to be 62, which is the correct answer. Okay, so we're probably doing this correctly here. Okay, so we're going to get part 1, and we need to go back to the original data. There we go, part 1 answer, and then we pass in the part 1 answer. Okay, 4830226. Let's find out if that is in fact the correct answer. There we go, correct answer. All right, so with that, let's see here. Can we be able to clean up any of this? I mean, it's relatively straightforward, I think. Just creating a new array. We've got a while loop. Yeah, let's call this test data is going to be this, and then we can just say min test data max test data. This is a little bit easier to read, right? If the sum of that equals my num, then we are returning both of those. Okay. While true, and then we return that. We don't really have a cap on this, so let's say while end less than length of data, because this the whole string of numbers, our value will always be less than that, right? We're never going to get beyond that as the test, I think. Okay. Okay. Cool. So let's double check that that works. Yes, it does. Okay. Excellent. Okay, so that's what we're going to stick with. This way we don't have an potentially infinite loop. We shouldn't, but now it's no longer while true, which I prefer. Okay, so with that, I think we're all done. If you have any questions, comments, concerns, accusations, throw those below in the comments below the video. If you like the video, please do remember to like and subscribe. Feel free to share as well if you feel like it. Other than that, have fun with Advent of Code, and I will see you in the next video.